Strap yourselves in. We're going to Mars. Not just a few astronauts, thousands of people are going to colonize Mars, and I am telling you that they're going to do this soon.
So your kids are going to live on Mars.
Some of you will end up working on projects on Mars, and I guarantee that some of your children will end up living there.
Hold my beer, says this company. We're going to send them there in the next 4 years. And here's their video from Time magazine.
CEO of Mars One, and we're organizing a manned mission to Mars in the year 2023.
And they got wall-to-wall positive media coverage.
Mars One has just taken another step to bring mankind where it has never stepped before. Meet the Mars 100.
From the initial 202,586 applicants, only 100 hopefuls have been selected to proceed to the next round of the Mars One astronaut selection process. These candidates are one step closer to becoming the first humans on Mars.
Then, of course, we've got this guy.
Wow, all right, so Musk said that SpaceX's long-term goal is to colonize Mars by the 2020s.
All right.
Well, coming back to this TED Talk, 2.5 million hits, 90-something% approval rating, and it's a TED Talk, a technology, entertainment, and design talk.
First, water is the basis of all life as we know it, and it's far too heavy for us to carry water from the Earth to Mars to live. So we have to find water if our life is going to succeed on Mars.
So this guy really must know what he's talking about, right? Or not.
So there's plenty of water there, but most of it's ice, most of it's underground. It takes a lot of energy to get it and a lot of human labor. This is a device cooked up at the University of Washington back in 1998. It's basically a low-tech dehumidifier. And it turns out that Mars' atmosphere is often 100% humid. So this device can extract all the water that humans will need simply from the atmosphere on Mars.
You see, sure, water is important to us humans. Really, really important. We're about 2/3 water by weight, which means if you're going to go to Mars, you're going to need some of it. But 100% humidity means almost nothing if you're going to change the temperature by a lot. I mean, let's just remind ourselves of what we're talking about here. We live under an atmosphere which is squidged to the Earth by gravity, and that squeezes on us and gives us a pressure on the surface of one atmosphere. Now, you can break that down into the fractional pressures of the various gases. So the atmosphere is about 80% nitrogen, so the partial pressure of nitrogen is about 0.8 atmospheres. And to a reasonable approximation, the rest is oxygen. Now, of course, there are some little numbers in there, like there's 1% of argon, and at 100% humidity, here on Earth, at room temperature, water is actually about 2% of our atmosphere. Now, atmosphere is kind of a big, chunky word to use here, so I'm going to switch to a more sciencey unit. 1 bar, to a very good approximation, is 1 atmosphere, or 1,000th of an atmosphere is a millibar. So at 100% humidity at room temperature, the vapor pressure of water is about 20 millibar. That means that if you're air over water, it will eventually saturate to 100% relative humidity, 20 millibar. But what if the air isn't saturated? What if the vapor pressure is only, say, 10 millibar? Well, in that case, you only have 50% relative humidity at room temperature. And likewise, if the vapor pressure is 5 millibar, then you only have 25% relative humidity at room temperature. But that changes completely when we change the temperature, because the ability of the air to hold water changes with temperature. So if we do this again over ice, well, the partial pressure of water over ice is still significant. 100% humidity over ice is about 5 millibar. So, 100% humidity can change by a factor of 4 just going from room temperature down to the temperature of ice. And if we go down to -20, the vapor pressure of 100% relative humidity goes down to 1 millibar. and at -40, it's 1/10 of a millibar. So if you go out at 100% humidity at the South Pole, there is still almost no water in the air, especially if you consider what you're breathing out. What you're breathing out is essentially 25-ish degrees air at 100% humidity. So it's the partial pressure of water in the air that you're breathing out is about 20 millibar. And if you do that at the South Pole, then it's going to cool down to -40, leaving only about 1/200th of the water in the air, and the rest you will see as condensation. So what's the average temperature on Mars? Well, it's about -60. Having 100% humidity at this temperature is all but pointless, as the atmosphere still contains something like 1,000 times less water than what it would contain at room temperature. So could you use a desiccant dehumidifier on Mars? Well, in principle, yes, but you would have to pump 2,000 times as much of the atmosphere through it to get the same amount of water as here on Earth. And that's assuming that these things can actually work at these really low levels of humidity.
It's basically a low-tech dehumidifier, and it turns out that Mars' atmosphere is often 100% humid. So this device can extract all the water that humans will need simply from the atmosphere on Mars.
But if you were thinking of trusting your life to this, it turns out he's even wrong about the 100% relative humidity thing. This is actual data from the Mars Curiosity rover. And you can see on the best days, you only get up to about 50% relative humidity at about -70 degrees Celsius. And on the worst days, you're down at something like 10% humidity at -65 degrees Celsius. And honestly, if I'm on Mars, the one phrase that I really don't want to hear is, oh, by the way, your life now depends on this really complicated desiccant dehumidifier, with the nearest spare parts being on the next planet 200 million kilometers away. In summary, getting water from the air here on Earth is one of the most common scams out there. Relying on complex machinery like this to stay alive violates the primary directive, which is the secret of a long life is to try not to shorten it. You see, in my last video, I showed how just to fuel the fire of your metabolism, just to keep you breathing, takes about 100 watts of power. And that goes up to about 500 watts if you're doing hard exercise. Now, the way your body gets that power is essentially by burning sugar. So you take in the oxygen and the sugar and you burn it to carbon dioxide and water. And that's where you get the energy to live. And my body is burning away. So a few years ago, I actually did this really neat demo just to show how much energy your body releases in a day by burning about the right amount of sugar that your body burns in a day. And I did it with an oxidant, but the amount of energy released is about the same, and the amount of gas released is about the same as the amount of gas that your body releases in a day. And the results are really quite impressive. Yeah, that's how much energy your body cranks through in a day, and how much carbon dioxide and water it produces. Now, to keep that burning going here on Earth isn't too hard, because we've got plenty of oxygen, it's literally all around us, and fuel. Once in space, however, you've got a problem. You basically need a chemical plant to turn that carbon dioxide and water you're breathing out. You got to pump energy into it and basically get back the sugar and oxygen you started with. Now, to a degree, in a big ecosystem, this is done with plants. But it's also been tried in a small sealed system. Remember Biosphere 2? It was about 10 people in a sealed system. Now, some have viewed it as a kind of hippie new age experiment, and to a degree, yes, but it still pulled in some valuable, useful, and insightful data. It turns out that managing a mini Earth like this is basically impossible. It immediately ran into problems like the pollinating insects dying out and cockroaches thriving. Now, these are things that could be potentially fatal in any such mission. But also, just the simple stuff like maintaining the air such that it contains the right amount of oxygen and carbon dioxide is much trickier than you might expect. Remember, carbon dioxide gets toxic at about 5,000 parts per million, and once oxygen gets down to about 5%, you eventually just die. Now, this ain't a planet-sized system you're dealing with, it's a small system, so it reacts much more quickly to relatively small stimuli. So it's not going to take 100 years or so for the carbon dioxide in the atmosphere to rise from 300 to 400 parts per million, but it's going to do that in hours. If your crops die, the CO2 they release from rotting will probably kill you long before the starvation does. You know, here on Earth, the tree huggers do it mostly for show. But in a small, confined system like this, if you don't intimately care for your environment, when it becomes unbalanced, you will die with it. Hell, even in this big biosphere, their oxygen dropped by 25% over a period of a year. If it continued at that rate, within 3 years, all the people in this biosphere would be dead. Life in any such system is on a knife edge. So can you do this? Well, on some scales, yes. I mean, the International Space Station basically does exactly this. However, if things go wrong on the space station, or you need some spare parts or consumables like food and water, it's only a few hundred miles away. And it's got capsules that you can get in and get back to Earth if things get desperate. And it's the most expensive piece of hardware that mankind owns. Trying to do this on Mars is in a different league altogether. Oh, and by the way, this biosphere would be a Garden of Eden compared to what a mission to Mars would be like. I mean, it all basically boils down to energy. Giving things the energy to get to Mars is expensive. Really, really expensive. Just to put it into perspective, these are lemons in orbit and they cost about $2,000 a piece. Then you have the psychological aspects of the prospect of spending the rest of your life in a room the size of a small apartment with 6 other people, with your lives constantly on this knife edge, dependent on technically complicated machines, the failure of any one of which could mean the slow death of everyone. Who is going to do this? Hell, this isn't a new concern. I recently put out a video on the Voice of Thunder channel where I go through all the various Apollo missions. Now, these were just going to the moon, a mere 250,000 miles away. And almost every single of the Apollo missions had a failure in it which could have very easily resulted in the death of the whole crew. And the moon is a cakewalk compared to going to Mars. Oh, and who are you relying on to develop all of the technology to get you there?
And the reason is this man is determined to make that happen. His name is Elon Musk. You got to ask yourself, can this guy really do this by 2025 or 2027? So I think it's a pretty good bet that the person who is revolutionizing the automobile industry in less than 10 years and the person who created an entire rocket company in less than 10 years will get us to Mars by 2027.
Oh yes, that makes sense. Look, Elon Musk's done some good things with rocketry, maybe reducing the launch costs by 2/3. Let's just give him that as a given, which is impressive, but it's not a game changer for going to Mars. Remember, lots of this is predicated on reusability. The assumption is that reusability does not impact reliability. I mean, remember the cheers when they recovered the boosters.
Side boosters landing legs are deployed.
And the Falcons have landed.
Now, sure, some of those recovered rockets might not have been in the best tip-top condition. You know, not the sort of thing you would have been happy just to, reuse by putting more fuel in and just firing them up again. But it's still fairly impressive that they got them back at all. Kind of like the space shuttle. It's nice to get these things back. or seeing this Dragon capsule dock with the space station. And they got that craft back, which is amazing. I wonder how the emergency abort system on that craft works now. Yes, that's the emergency abort system. That's what you light up when you want to get the crew safe from an exploding rocket. Now you might say, well, yeah, but I read somewhere that they're only going to reuse these Dragon capsules for cargo to take to the space station, which is a nice idea. But those are also the engines that are used to control the craft in orbit. How does that idea of reusing spacecraft for docking with the space station feel now? Look, the bottom line is reusability is not a silver bullet. Reusability at the cost of reliability is a false economy. And if you're honest, the Dragon capsule is just a clone of the Apollo command module with maybe a lick of paint. And this is one of the reasons why I single people like Elon Musk and SpaceX out for criticism, is because they promise the world.
Musk believes that he could send 2 BFR cargo ships to Mars by 2022, with the first 2 crewed crafts touching down just 2 years later. How the BFR could be used in other ways. For example, the same technology could fly people anywhere in the world in less than 1 hour, potentially revolutionizing global transportation, with passengers paying essentially the same as they do now for a commercial airline ticket.
Well, the graphics are beautiful. The snake oil smells fantastic. But fundamentally, this is vaporware. In reality, they are struggling to replicate the command module. Not that that's a real criticism. Space is difficult. This sort of thing is actually par for the course with spacecraft design. Yes, they had similar problems when they were designing the command module.
This is Houston. Say again, please.
Houston, we have a problem. We have a main bus B undervolt. We've got a lot of thruster activity.
But North American aviation were not going around at the time saying that in 10 years' time, going to the moon will be so cheap and easy that people will go there for afternoon picnics. And that's the issue that I have with people like Elon Musk and SpaceX. This isn't a revolution. This is a replication of what was worked out with the Apollo missions some 50 years ago. And in this case, one that still has quite a few bugs to work out of the system. Yes, this is impressive, but so was this 50 years ago. What radical improvements have been made? They're still essentially the same rockets. All right, it's maybe half the cost. Great. Now what? You've just got to make it 1,000 times more reliable and 100 times cheaper, and you've maybe got a chance of this bargain basement trip to Mars that you're talking about. And if you think these people, Mars One, were crazy, promising to go to Mars for a mere $6 billion.
The total cost of having the first 4 humans, including all the preparatory missions that we do before the humans go, is about $6 billion US.
Now, there has been some criticism saying that that figure is too low.
That's about $1.2 billion per person. Elon Musk is promising to get them there for $250,000. That's 10,000 times cheaper than these guys, who were, and let's be fair, were completely unrealistic. And all of this is kind of built on the back that making rockets 1,000 times more reliable is so easy that the only reason it's not been done by the thousands of rocket engineers who have worked on this for the last 50 years is because reasons. Look, let me put this in car terms. If someone comes up to you and says, this is a complex piece of machinery, it's going to cost $20,000 to build one of these. And then someone like Elon Musk comes on and says, yeah, but in 10 years' time, I'm going to be able to make those exact same cars for $2. 10,000 times cheaper. You would rightfully be skeptical about such a claim. So why do you believe him when he makes these claims about rockets?
So I think it's a pretty good bet that the person who is revolutionizing the automobile industry in less than 10 years and the person who created an entire rocket company in less than 10 years will get us to Mars by 2027.
So this guy is in the firm belief that the man who is over 4 years late launching men, just not going to the moon or anything, just getting them into space, will overcome all of these problems of keeping men alive in space for 6 months and getting them to live the rest of their lives on Mars within 10 years. This is vaporware. Hell, the capsule that's meant to be taking people into space isn't just 4 years late. It's probably going to be pushed back at least another year till they work out why their manned capsule exploded. Now, sure, no one was in this thing, it was just a test. And these are just the technical challenges of redesigning the command module. This isn't even getting into the race to go to Mars proper. This is just getting out of the starting gate. This is just getting a capsule that can go into orbit.
Elon Musk just announced his plans to begin colonizing Mars. He proposes that he could have humans on Mars by 2024 and use the same tech to get people to travel anywhere around the world in under 1 hour.
Look, there's no problem in having your head in the clouds as long as your feet are on the ground. Let's tinge this snake oil here with just a hint of realism. Is going to Mars possible? Yes, but you're going to have to spend real money to do it. Something like take NASA's budget and add a 0 to it. Now that's big money, but maybe not as big as you think. It's still comparable to what the US military spends each year. Or it's on the same scale as just the tax breaks that religion gets off the US government every year. And that's not including all of the money that people just give to religion in America. Yeah, and what comes out of all this? You get the Mars One estimate that they could do it for 1% of the cost of this, or Elon Musk's estimate that he can do it for 1/1,000,000th of the cost of this. And if you believe that, I've got a great mass production car that's going to be on sale in just 10 years' time for the bargain price of $2. And you're welcome to invest in it as much as you want. Damn, Elon Musk claimed that they were going to land one of his Dragon capsules. You know, this thing. They were going to land one of those on Mars in 2018. That's last year. Using exactly these rockets to land the capsule.
SpaceX founder Elon Musk tweeted out Wednesday that he's hoping to land one of his capsules on the surface of Mars in May of 2018. That's
not that far away.
No, that's...
But vaporware is not uncommon when it comes to Mars. The only thing that's improved is the quality of the graphics. I mean, remember Mars One? It started in 2012.
Mars One has designed a mission that is much simpler than previous designs for Mars missions.
I will tell you how we will go to Mars, and I will tell you where we are in the timeline of this mission.
With the intention of getting us to Mars in 2025, and everyone loved it. It had Nobel Prize winners on board.
This is really something that can be achieved. I think this might become a most spectacular media event ever, watched by everyone on the globe.
They had a plan.
This is the plan. In 2016, a communication satellite and a supply mission. 2018, a large planetary rover will be sent to Mars.
In 2020, living units, life support units, a rover, and more supplies will be sent to Mars. The rovers will prepare the settlement for human arrival. The crew will depart in September 2022.
April 2023, the humans will land on Mars. The next giant leap for mankind.
They had all sorts of contractors lined up.
They confirmed to us that they can supply the required equipment. For every component, we have at least one potential supplier. All these suppliers have written letters of interest for Mars One.
They had people submit videos for people who wanted to become the first Martians.
Already people are uploading their application movies to our website.
Initially, more than 200,000 applied for the Mars One astronaut selection program from all over the world.
It's really fun to see people explaining why they want to leave everything they have here on Earth and start a new life on Mars.
I like to travel around the world and see different things. Went a year later to Sierra Leone. Also, maybe Mars is the next step, you know.
And they were going to finance it through donations and a reality TV show?
And I think that reality TV from Mars will be completely different than reality TV from Earth, because reality TV from Mars is inherently interesting. Telling this story, the biggest adventure of mankind to the world, that will be our way of financing it.
I wonder how that's going now. Oh, they've gone bust. I'm stunned. Hyperloop one, sorry, Mars one has just gone bust. Who could have seen it coming? Now, maybe I'd cut him a little more slack if his promises had been more realistic. But they weren't. I mean, this isn't so much going to Mars in 10 years, but going bust in 10 years. And let's be realistic about what's going to happen if you got these people to Mars. They're going to spend the rest of their lives in a tiny cave.
There is too much solar radiation and too much radiation from cosmic rays. So we really have to go underground.
Not that different to a cave that you would have here on Earth.
Or we may choose to live underground in caves or in lava tubes, of which there are plenty.
This is hardly the romance of exploring strange new places. It's sitting in a cave for the rest of your life. If you wanted to be the first person to spend the rest of your life in a lava tube, you don't have to go to Mars to do this. There are plenty of uninhabited and unexplored lava tubes here on Earth. Look, I understand how this could be wonderfully iconic.
This is going to be a media spectacle. Big Brother will pale in comparison. The whole world will be watching and experience this journey.
To have man land on Mars, a defining moment in mankind's history. But I also know enough about keeping people alive in tin cans, in small confined systems, to know that romance of the first humans looking out and seeing sunset on a different planet will be followed by a lifetime of regret, stuck in a small cave trying to maintain the life support package whilst 200 million miles away you've got a green, sunlit upland where people are enjoying a barbecue. To me, it's all got an air of Scott of the Antarctic about it. This was a famous British explorer. He wanted to be the first human to reach the South Pole. And he did actually make it to the South Pole, where, and I kid you not, he found a Norwegian flag from Amundsen, who had been there just a few weeks earlier. And on the way back, they started to run out of life support package. They started to run out of food and fuel. They started to freeze, and they knew it would just be a few days till they were all dead. And we know all of this because after they froze to death, they found Scott's diary, which echoes the desperation of the place they had found themselves in. Great God, he wrote, this is an awful place. And you can almost feel the last entry. Every day we've been ready to start for our depot 11 miles away. But outside the door of our tent it remains a scene of whirling drift. I do not think we can hope for any better things now. We shall stick it out to the end, but we are getting weaker, and of course, the end cannot be far. It seems a pity, but I do not think I can write any more. Robert Scott, last entry. For God's sake, look after our people. This is what the universe is like for humans in merely a slightly inhospitable place. And now, it's true, we have a base on the South Pole. But if you ask people to spend the rest of their lives there, I think you would have very few takers. And the conditions on the South Pole are a paradise compared to what you would get on Mars. Now, do I support the idea of trying to get off planet? Yes. God, yes. But likewise, I also understand that the only people who would volunteer to go are people who don't fully understand what they're volunteering for.
What life on Mars will be like. We want the world to elect the envoys of mankind to the next planet. The final vote will be given to the audience.
Out of this group, just 2 advanced to the final 100. Layla Zucker, a married 46-year-old ER doctor from Washington, D.C.
Spaceship, spaceship, spaceship!
And Daniel Carey, a 53-year-old data architect from Virginia, husband and father of 2.
Look, space is difficult. Really, really difficult. Manned spaceflight, doubly so. Manned interplanetary missions rise to the level of insanely difficult. And the reason that a lot of people like the Elon Musk sales pitch is he makes it sound fun and easy. You know, why don't we just do it? We can be there in 6 months, a year tops. It's a pretty fantasy. It really is. And I understand why people want to believe it. Comfortable fantasies have always been easier to sell than ugly truths. But I'm not a fantasy merchant. I'm a reality merchant. I'm not here to whisper seductive lies, but to unmask those who whisper the seductive lies.